Welcome to the Journey Chez Chem. Today's warm-up, you have some review, one combined gas law problem and one combined gas law problem with a cow collected over water. Do them to the best of your ability, and I'll be back in a moment. In number one, it's very important to write a table of variables. I am given my initial volume as 505 decimeters cubed. My initial pressure is 640 torr. I'm given a temperature in degrees Celsius, and we must always change to Kelvin, and that would be 323 Kelvin. My V2 is my unknown, and I am going to standard pressure and temperature, STP, standard temperature and pressure. Then I write my combined gas law, and then I rearrange it for my unknown. And the reason that we do this is so it is less likely to make mathematical errors if you're rearranging these variables rather than numbers with units. It's much more straightforward. Then I just put in my numbers, 505 decimeters cubed times 640 torr times 273 Kelvin divided by 323 Kelvin times 760 torr. Now remember, 505 times 640 equals, times 273 equals, divided by 323 equals, divided by 760 equals. And my number comes out to be 359.4329. I want 3 significant digits, and therefore this 4 does not round the 9 up. It is 359 decimeters cubed. Then I have a little conversion that I need to practice. Centimeters cubed is what I'm looking for, and decimeters cubed is what I am given. And we know that there are 10 centimeters in 1 decimeter. And therefore, when I cube 10, I get 1,000. There are 1,000 centimeters cubed in 1 decimeter cubed. And whenever I make a conversion, I'm not changing the number of significant digits. That's why I could round it to my number of significant digits first. And therefore, I get 3.59 times 10 to the third centimeters cubed. Oh, to the fifth. Because this number is the same as 3.59 times 10 to the second. And 2 plus 3 is 5. Always double check our math and make sure we're coming up with the right number. And that would be my final answer for number one. Number two, I noticed that we're having a cow. Well, remember that this is an instructional tool to help you understand that when we see cow means that it's collected over water. And you may not see that cow on an assessment or a quiz. It's expected that you understand collected over water equals cow. And therefore, make sure that you pay attention when you're taking those assessments. Now, on here, I am given volume, pressure, and temperature. However, because it's collected over water, I have to figure out the pressure of the dry gas. And that equals the pressure of the total minus the pressure of the water at that temperature. And you'll notice that we're at 55 degrees Celsius, and that's not given on the sheet. So we have to interpolate or take the average between 50 and 60 in order to get that pressure. Now remember, this is actually Dalton's law, and Dalton's law tells me that the sum of the partial pressures is equal to the total pressure, and therefore I'm using it to get the pressure of the dry gas. I am given the total pressure as 97.5 kPa, and I'm going to subtract my pressure, which is 16.1 kPa, when I get the point that is halfway between 50 and 60. Now, when I have the 97.5 kPa minus the 16.1 kPa, my initial pressure, or the pressure of the dry gas, is 81.4 kPa. That part is Dalton's law. And then we just go from there, and we are in the combined gas law. We are changing it to standard conditions, and I know the combined gas law is V1P1 over T1 equals V2P2 over T2. And therefore, my V2 is equal to V1P1 over T1 times T2 divided by P2. And remember, we make fewer mistakes if we rearrange it and then put in the numbers. Now I will put in the numbers. 350 milliliters is my V1. 81.4 kPa is my P1. My T2 is standard temperature. My T1 is 328 Kelvin. And my P2 is 101.3 kPa. We must always use the same units. And when I do the math here, I get 234.0840 milliliters. And I know I must still make a conversion, but I'm going to go ahead and round to the number of significant digits required in my answer. And that would be 3. Therefore, the 0 does not round the 4 up. I have 234 milliliters. Now, we are asked for centimeters cubed. And 1 milliliter is 1 centimeter cubed. Just checking to see if you're paying attention to those things. And therefore, my answer is 234 centimeters cubed of this gas. And that's how you do number 2. Now here's something for you to try. It's so much fun. I'm showing you Boyle's law. Now we know that Boyle's law is V1P1 equals V2P2. The relationship between volume and pressure is that they are inversely proportional. One goes up, the other goes down. And that is inversely proportional. Now, I am going to increase the pressure on this 2-liter bottle with water in it. And as I increase the pressure, I squeeze it. And that causes the bubble that's in the eyedropper to decrease. I increase the pressure and I decrease the volume in that rubber stopper, in the eyedropper, and that will cause it to drop to the bottom. When I release the pressure, I decrease the pressure and I increase the volume of the air in that eyedropper, and it goes back up to the top. Now look, isn't that fun? I squeeze it, it drops to the bottom. I release and it goes back up to the top. Squeeze increases the pressure, decreases the volume. Release the pressure, increase the volume. Increase the pressure, decrease the volume. Decrease the pressure, increase the volume. And that's Boyle's law. And that was some fun, and you can do this at home as well. 2-liter bottle of water and an eyedropper is all that's required. Well, that was some fun, and I can't wait to see you tomorrow. Bye.